Hello and welcome to VisualMILL 2016. In this video, we discuss and demonstrate the new Xpress configuration while programming 2.5-axis, 3-axis, and whole machining operations on a 3D part model. VisualMILL Xpress is ideal for makers, hobbyists, and students looking to get familiar with CAM for the first time. If you're ready, we invite you to sit back and enjoy the demonstration.
So today we're going to take a look at the new module that's been added to our mill configurations. We have an Express configuration that's been added to our milling module. So now we have Express and then Standard, Expert, Pro, and Premium. The Express configuration offers 2 and 3 axis capabilities, and this is a great feature set for for somebody who is starting out with CNC programming or looking for some 2 and 3 axis milling and whole machining drilling features. Now to run the product, locate your Visual CAD CAM shortcut on your desktop, and from the Get Started dialog you click on Run CAM Demo, and then under Choose CAM Configuration you'll now have the option. So select Express, select that, and then click on Mill, and this would launch the Visual CAD CAM with the Express configuration for the mill module. You'll now see the Machining Operations browser over on the left panel, and right below the Machining Operations browser you have the Machining Objects browser. Now, the Machining Operations browser has 2 tabs: you program and simulate, similar to various of our other configurations, and you have access to 2-axis and 3-axis methods. Under 2-axis you have facing, pocketing, profiling, and engraving. Under 3-axis you'll have horizontal roughing and parallel finishing, and drilling under whole machining. Now as far as the tool types goes, you will have access to ball end mills, flat end mills, corner radius, V-mills, and drill tool. You can assign properties for each and every tool, set up your feet and speeds. You can also use the built-in feet and speeds calculator to establish your feet and speeds based on the material you're working with, and save these tools to a library and load from the library.
So Uday, do users get a predefined tool library, and you can create a library and save it in this version?
Yes, a standard library for inch and metric units are included.
Good.
Users can also create their own library and save and load those libraries.
So just like in all the configurations, you get the same functionality in Express then for tools?
Yes, the number of tools, or the type of tools, tool types, what you see in the Express configuration is restricted to ball mill, flat mill, corner radius, V-mill, and drill tool.
But all the library,
you need more tool types.
Yeah.
Yes. If you need additional tool types, let's say for example you need a taper tool where you can define a taper ball mill, or you need to define a face mill or a fillet mill or a user-defined tool, for those you would need to upgrade to the standard configuration or higher.
Okay.
So these are the 5 different tool types that are included in Express configuration. And you can save and load tool libraries. You can set your feeds and speeds using load from tool, load from file to establish it. Since Visual CAD CAM 2016 runs inside our Visual CAD framework, you have the same set of CAD tools that are offered in all of our configurations. So you have access to all the set of file translators. You have a very wide range of file translators in here. You can import files from your existing VisualMILL formats. You can bring in files from 3D Studio, Illustrator, AutoCAD, DXF, DWG, IGES. You can bring in OBJ, Parasolids, point data, raw triangle files, native Rhino files, SAT, SketchUp files, STEP, STL, U3D, and VRML. So Visual CAD offers you a wide range of file translators.
That's impressive actually, because a lot of times you used to have to pay a lot of money just for a set of translators, and they come free with AutoCAD. I mean with Visual CAD.
That is correct. And when you're working with for creating 2-axis toolpaths or 2D toolpaths, you could just work off 2D drawings. You don't really need to have a 3D model. So if you have a 3D model, you can use a 3D model and you can take measurements for your depth, and you can use the 3D model for better visualization purposes. But you can still work with just 2D drawings as well for programming 2-axis toolpaths. So I'm going to go ahead and load one of these parts. I'm going to pick an IGES file format and then select Open. And Visual CAD automatically translates these files, and once the file is translated, you can view it in different viewports. You can also resize these viewports in here. You can maximize it, double click on a viewport to maximize it. You can zoom in and zoom out. It has very nice and powerful viewing tools. In addition to several of these file translators, you have tools for your display, modeling, you have curve modeling, you have several drawing tools in here for creating 2D drawings, starting with points, lines, circles, and arcs. You can also create NURBS curves, and you have curve editing tools. In addition to these, you have surface modeling tools, solid modeling tools, mesh modeling tools, dimensioning tools, and analysis tools. So all of these CAD functionalities are available in the Visual CAD CAM's Xpress configuration. Now, once you have a part loaded in here, we are now ready to program some toolpaths. Step 1, go into the machining browser under the Program tab, and you establish your machine tool setup. Now, in this configuration, the number of axes is limited to 3 axes. So for both 2 and 3 axis operation, you would select 3. Now, if you need 4 and 5 axis capabilities, the 4-axis capabilities available starting with our Expert configuration, and 5-axis index capabilities available in the Pro, and simultaneous 5-axis is included in the Premium configurations. You can refer to the feature list on our website for a detailed set of features. The next step is to select your post-processor. The Xpress configuration includes the same set of post-processors that are available in all our configuration. This means you have access to over 225 different post-processors, which covers a wide range of machines tools that are out there. You can also edit your post-processors and create new post-processors. You can create new posts for pretty much any machine tool that reads standard G&M code or ISO G code.
So the same post-process generator you get with the Express as you get with all the configurations?
Yes, that is correct.
Wow.
And you can establish your posted file extension. You can use NC, CNC, or if you need to add your own extension, you can select Add New to add it in. Next step is you want to establish your orientation. So you want to make sure that the part is oriented correctly. So looking down from the top view in your world coordinate system orientation, make sure that the part is oriented correctly for machining. If you need to reorient your part, you can go under Setup and then choose Orient Part to change the orientation. So in this particular case, we're going to machine it from the orientation that you're looking down from the top view. So we're going to maintain the same orientation, so we'll pick OK on it. Now, as you notice here, once you make your selections, these are automatically being updated in the machining job under the machining browser. The next step is to select your stock geometry or define your stock or the workpiece that you're going to be mill this part from. You could select stock, and you can define your stock as a rectangular stock from one of these 2 methods. You could use a box or a part box stock. In the box stock, you can specify the length, width, and the height. By default, the system automatically computes your stock extents based on the part geometry. You can enter in your length, width, and the height, or you could use the part offset stock, where you can actually specify a part box stock, where you can specify the offsets in X, Y, and Z. So the stock would be rectangular but slightly larger than the extents of the actual part itself. So this would be the box stock, where you can enter in your length, width, and the height. Alternatively, you could use the part box stock in here to establish your dimensions with the offsets in X, Y, and Z. Now, if you need additional stock types, if you want to have a stock that's cylindrical in shape, or if you need to have a stock that would be a true offset, or if you need a stock by extrusion or stock by selection, these options are available in higher configurations. For example, the standard and export includes cylinder stocks. The pro and premium includes part offset stock, stock from extrusion, and stock from selection.
So that stock from selection, you could actually export your stock from the current cut material simulation and then import that again as a stock selection. Is that basically what you can do?
That could be one of the applications. You could also have your stock modeled in your CAD application, and then you can select it to define a stock by selection as well.
Okay.
So once you have your stock defined, you can click on Stock Visibility, and the stock is displayed on your screen. And when you go to the Simulate tab, you can view the transparency of the stock. This is more opaque in the Simulate tab, and it's more transparent in the Program tab, and you can set these transparencies in the simulation preferences. And now the next thing we're going to take a look at is how do we align this to the part and then start programming some toolpaths. So we're going to go to Align, and we're going to pick Align Stock, and I'm going to choose Align Z to the bottom and have it centered in X and Y. So the bottom face of the stock is flushed with the bottom face of the part and centered around in X and Y. So that way you can remove material from all the sides. Now once you have the stock aligned to the part, the next step is you want to establish your origin. So you're going to go to Set World CS under Align, and you can pick your origin location. You can either pick a point graphically, or you can use Set to Stock. You can do Higher Z, which is the top face of the stock, and we'll pick Southwest and pick OK. So the part and the stock are now aligned, and the origin is set to the southwest corner and the top of the stock material. So the part and the stock are automatically transformed to the CAD origin or the WCS origin. So this would be your program 0, or it could be your work coordinate 0 for milling this part. So when you place this stock blank on your CNC equipment, you're going to be zeroing it out at the southwest corner and top of the stock. Now one of the alternative ways to establish the part 0 or the program 0 or the work 0 is using this feature called work 0, where you can transform the coordinate origin by selecting a set to stock, set to part, or you can use a pick. So for example, if you want to put the origin to the center of the circle or center of the hole in here, you can use the pick option and use the snaps in here to go grab the center right there, and your work 0 could be set right to the center of the whole feature. So your world coordinate origin still remains at the southwest corner, but you could be setting your machining origin to the center of the hole. So the work 0 transforms or translates your coordinate system origin from the world coordinate system origin for machining. Now if you'd like to use the
work 0, you don't really need that if you don't want to use it. Is that right? I mean,
if you're going to be establishing your program 0 to the same location where your world coordinate system origin is set to, then you wouldn't need the work 0, and you can delete it out.
Okay.
Now once you've established this, you're now ready to program your toolpaths. I already have some tools loaded from my library, and we are now ready to program it. The first step I would like to do is face the stock blank to bring it down to the thickness of the part. I could use some of the CAD tools in here to create a boundary around it. So for example, I could just throw in a boundary in here that represents the extents of my stock right there, and I can go into 2-axis, use facing. Now there are 4 different methods that are offered in the Xpress configuration. You have facing, pocketing, profiling, and engraving. So I would like to face it. I'm going to use 2-axis and facing. For the part regions, I could select the rectangle I just created. Now you'll notice that the part region feature is available in all our configurations. If you're looking to have any avoid regions, you would need to have standard or higher configurations. You would have to upgrade. So you can select the part region or a containment region or your drive region in the facing operation. The next step is to select your tool, and I'm going to pick a 3/4 inch end mill from my library. If you're looking to use a face mill tool, if you want to define it as exactly like a face mill, then you would need to have one of the higher configurations of the product, or you could define it as an end mill to program it in here. And then you set your feet and speeds, specify your clearance, set your roughing parameters. You'll notice that you can set your tolerances for facing, your stock allowance, You can choose your cut pattern. You can go linear or offset cut pattern, your cut direction, and you can also specify your step over control. And under cut levels, you could actually pick the depth. So you can use the pick button in here, and you can actually snap to the geometry. So working with the solid geometry makes it easier for you to actually pick the depth in here as you see it. So the total depth from the top face of the stock to the top face of the part is little over 68 thousandths. You can also set your entry and exit parameters and then pick generate. And there's your facing toolpath, appears right on your graphics screen. You can also toggle the display of the toolpath. Now additional options like arc fitting and advanced cut parameters, they're all offered in the higher level configuration starting with standard.
There's one thing I wanted to ask you before you simulate that, Uday. In those two-axis menu, what are they getting again versus what's in the next the standard configuration?
So the standard configuration, which is one level above or higher to the Express configuration, offers you more options, like you have high-speed pocketing, two-axis roughing, you have V-carving, chamfering,
right,
hole pocketing, hole profiling, thread milling, T-slot machining.
Okay, so basically what you're saying is the standard configuration, the next one up, has all the two-axis operations that we offer, almost all of them.
Most of the two-axis operations except remachining.
Right. Okay.
Now, once you generate your toolpaths, you can go to the Simulate tab, and you can hit the play button to run your verification. You can slow down the simulation speed, and you can watch the simulation. Now, the Express configuration includes our homegrown simulation, which is the voxel simulation model, so you can simulate both 2 and 3-axis operations. Now, starting with the standard configuration, you'll also have the option to use the advanced simulation engine, which is the polygonal simulation module, which basically gives you a much finer resolution on the simulation. As you may notice, some artifacts would show up in Z levels with the voxel model, as the resolution of the stock model is not very fine with the voxel simulation model. And we'll go with that as we program additional features on this part. Now, we already phased it out in here. The next step is you may want to pocket this feature. So you could use a two-axis pocket operation in here. So select two-axis and pocketing. You could select the feature to pocket and just directly select a face edge or a surface edge from the model. So we are selecting the face edge from the model right there. So there it is. And then you grab a tool. So I could say I want to use a 1/2 inch end mill. Set your feeds and speeds. You can use load from tool or load from file to compute it. Specify your cutting parameters in here. You can specify the cut pattern. In this Express configuration, you could choose between offset and linear cut patterns. Now, additional cut patterns are available in starting with the standard configuration, like offset spiral, and radial cut patterns. You could choose your cut direction. You can specify your step over. And in the cut levels, you can determine the depth. So you can use a 2-point pick to pick a point near the top edge, and you can pick a point near the bottom edge. Now, in our higher configurations, you have a very nice feature called Determine 3D Model. Use 3D Model to detect depth. So the depth can be automatically determined based off the 3D model. Now, this feature is not available in the Express. It's available starting with the standard configuration. You can now specify your depth per cut. So I'm going to put in 100 thousandths. Set the entry and exit parameters in here, and then pick generate, and there's your pocket toolpath right there. So there's your two-axis pocketing. So as you select arcs and circles, automatically arcs are fitted to the arcs. Now, if you have a spline or a polyline, then it would be output as linear segments. Now, if you need additional options like arc fitting, advanced cut parameters, and also you need sorting, those are available starting with our standard configuration. And there's your cut material simulation. You could always hit the pause button and simulate to end if you'd like to run through the simulation. Now, as I pointed out earlier, the resolution is not very fine along the z-axis, you may notice these artifacts during simulation with the voxel model. If you need a much finer simulation, you could upgrade to one of the higher levels starting with the standard configuration. Now we already pocketed out this feature. The next step is we want to rough the exterior. We're going to program that using a horizontal roughing. This method is also known as roughing in levels, or also Z-level roughing, and this is a great way to rough your stock to bring it as close as possible to the finished shape of the part geometry. And there's your tool that you've selected. You got your feeds and speeds. You can put in your cutting parameters in here, specify your stock to leave, and again in this particular method you have your cut pattern. Either you can set it to offset or linear. Additional options for other additional cut patterns are available starting with the standard configuration. You can choose your cut direction, specify your cut levels in here. You can specify your engage and retract parameters and then pick generate, and in this process it will create your roughing toolpath. And there's your roughing in levels toolpath. You can view the toolpath and also display the toolpath as you step in each level.
So again, similar to the 2-axis, can you tell me again what's available in the standard on 3-axis versus the Express?
Yes, in the 3-axis with the Express configuration, you have offset and linear cut pattern. Starting with the standard configuration, you'll have offset spiral, radial, and spiral cut patterns. You'd also have the advanced cut parameters where you can perform arc fitting, you can perform corner rounding, and you can perform smooth cut connections. The advanced cut parameters are available starting with the standard, so they are not available in the Express configuration.
What are the extra 3-axis operations you get with this standard versus we have two 3-axis operations here in the Express. What else do you get in the standard? That's the next higher up.
In the standard configuration, in addition to these, you'll also get horizontal finishing, or also known as finishing in levels,
right.
Z-level finishing, radial finishing, and spiral machining.
Okay, so you get more toolpath types.
Mm-hmm. And that's your roughing simulation. So that's roughing in levels. It's a very powerful feature set for the Express configuration. Offers you 3-axis roughing, 3-axis finishing, and several 2-axis methods. Now once you've roughed it out, you'd probably want to go back and profile finish the inside. You could do a 2-axis profiling and finish the inside hole feature. You can use a same flat mill, specify your cut parameters in here. Now you'll notice that there are additional options like determine the side to place the cutter using a 3D model. This option is only available starting with the standard configuration. With the Express, you could choose outside or inside to choose which side to place the cutter. And also the option to use 3D model to detect depth is not available in Express configuration. So you would need to have one of the higher configurations. And if you're looking to perform sorting of multiple profiles, or you need to be able to create bridges and tabs, which are part of the advanced cut parameters, those options are not available in the Express configuration. The Express configuration does include 2-axis profiling. It does include the option to specify all your cutting parameters in here. You can specify your cut levels and depth per cut. However, if you need more options, you can always look at the standard configuration as an upgrade path. There's your profile operation. Now let's go ahead and drill these holes and then finish the outside exterior. So you can go to hole machining and choose drilling, and this lets you do either a standard drill, you can do a deep drill, brake chip, or countersunk. You can select hole features by just selecting these flat areas, holes on the flat areas.
Oh, that's nice.
You can go grab a tool for it. So we could select a drill tool, or you could use an end mill for it. So I'm going to go with an 1/8" drill bit. Set your feeds and speeds and clearance, and then in the cutting parameters, You could determine the type of drill operation you'd like to program, whether you want to do a standard drill, deep drill, countersunk, brake chip, or a user-defined drill cycle. I'm going to go with a standard drill, and then I'll pick the depth in here, pick the top face, and then the bottom edge as it's being a through hole. I'm going to also select Add Tooltip to drill depth and generate it. Now if you need to be able to sort the sequence of holes, then the sorting option is available starting with our standard configuration. So it'll sort or go drill the holes in the sequence in which, or the order in which you selected the holes. If you need to be able to sort it, then you would need to get one of the higher configurations. Okay, next step. We want to go ahead and finish it. So we'll go to 3-axis and we'll use parallel finishing. And we'll select a tool. Typically for parallel finishing, you'd want to pick a radius tool. This could be a ball mill, or this could be a corner radius tool. So I'm going to go with a 1/4-inch ball mill, set the feeds and speeds, and set the clearance. And in the cutting parameters, I could choose the cut direction. I can also establish the angle of cut, so you're not restricted to any angle of cut. So you can enter any angle. So I could put in, for example, 90 degrees, or I could put in 45 or 315, any angle. You also have the option to ignore the holes, so it'll automatically ignore these holes. You can control your step over in here. And if you need to do any containment in the Z, you can specify a Z containment, and selecting Generate will create your toolpath. So there's your parallel finishing toolpath.
That's a lot of options. That's a lot of options for the Express configuration. You have a lot of control over that.
Absolutely. And you can see that the ignore holes automatically skips those holes.
And you could run one. You could run one parallel finishing at 90 degrees like that, and then run another one at 0 degrees, and
absolutely
nice finish on that part.
And that'll basically go ahead and clean up any scallops that you may have left in a cut direction when the angle of cut is set to 90 degrees. You can copy and paste operations, double click to edit, change your angle of cut, generate it, and there it is.
Nice.
You could always pause and pick Simulate to End. Now once you have all your part programmed, you can look at the estimated machining time. Right mouse button click and select information. We'll display the total cutting time, and it shows the machining time for each operation, and also list the tool information in here. Now, to be able to post-process your toolpaths, you would need to have a valid license for the product. So once you purchase your product, you'll be sent out with an activation key, and you can enter the activation code and register your product. Once the product has been successfully registered, you will be able to post and save your machining operations. And there it is. There's your posted output file, and it does output your tool changes. So depending on what post processor that you select from the list, you can select your post processor in here. And I'm going to go select Haas, and then post process it. And there's your posted output file. There's your G54, your work offset. Then calls up your tool number, set your spindle, and there's your code right there.
One thing that I think is really very impressive about this configuration is the fact that you get the complete post-process generator. Could you show us that real quick? That's the same.
Absolutely.
That's the same post-process generator and editor that you get in the highest configuration that we offer.
Absolutely. So this post-processor set is the same. With the Express configuration, you'll be able to program 2- and 3-axis toolpaths.
Can you show us the editor real quick?
Yep, you select the edit button in here, and there's your post generator.
You get a lot of options there. You can control just about everything about the post.
That's right.
Nice.
And saving your work will automatically save all of the CAM information to the CAD geometry, the visual CAD part file. And one of the nice features you can also do here is generate a shop documentation. Right click and then select shop documentation. You can right-click on a setup, or you can right-click on the machining job and then select shop documentation. You can pick a template and then hit save. So this generates a setup information sheet, so the operator on the shop floor can be well prepared what to expect to machine the part, and you can also get information about the tools, the parameters like feet and speeds, the stock dimensions, the total machining time. So all of this information is published in the shop documentation.
I noticed too when you right-clicked on the machining job tree, it had the knowledge base functions. You can save knowledge bases and everything in this configuration also?
No, knowledge base feature is only offered starting with the standard configuration.
Okay.
So you have to upgrade. So the knowledge base feature allows you to save and archive your entire workflow of operations, so the same operations can be applied
Okay. So
on
that's in the
other
starts and
parts or
standard.
family of parts. Yes.
Okay.
So this basically gives you an overview of the feature set of the Xpress configuration for Visual CAD CAM 2016.